React 19 has been released, and with that we have major changes to 3 hooks. There's a big change to one of the newer but existing hooks, useTransition. We have 2 new hooks available, useOptimistic and useActionState as well. So in this video we're going to go through examples of all 3, and by the end you'll know exactly how to use each of these 3 hooks. UseTransition has been around for a while, but React have made some substantial updates to it with the release of React 19, mainly that you can now pass async callbacks to useTransition, which previously was not possible. So I'll go over 2 examples showing 2 of the main benefits of useTransition. But looking at the React docs, they describe it as useTransition is a React hook that lets you render part of the UI in the background. Now that is actually a little bit misleading. So let me show you 2 examples of how useTransition can be used and why this is misleading. So in the first example, we have this component here called show me slow component. When I click it, we're going to render this slow post, which has a while loop inside it, which is forcefully slowing the component down. So it's going to cause the component to take at least 1 millisecond to render. Inside slow component here, we're rendering 500 of these posts. And then inside our transition example, we are rendering a button here, which has an action set completed. So when the button's clicked, action will be called, changing set completed to true, which will then render the slow component. Importantly, inside button, we have the useTransition hook. This is returning us a function called startTransition. And importantly, because the action, so the action attached to the button here, is called inside startTransition, React is going to treat that as work that needs to be done in the background. So when it tries to render each of these 500 posts, it will be able to be intelligent enough to optimize all of those posts individually. So that means when I click show me slow component, I'll still be able to see the hover states and then click these tabs if needed. So normally that wouldn't be possible. If I take action outside of startTransition, for example, and then comment this out, if I do this again, the UI has locked up until these posts render. See that? And that's because when action is just called in the normal way, React doesn't know that this is work that can be done in the background and therefore doesn't optimize it. Now, the reason this is misleading is because the example is set up in a very specific way that allows React to actually optimize, and that's because I'm rendering 500 individual posts, meaning React will get 500 jobs, you might say, pushed to a queue, which it can then crunch through one at a time, but then also focus on other parts of the application. So it might render, say, the first 10 posts and then focus on something else and then come back and render 10 more posts. But if I change the example, so we're not rendering individual posts, so let's take the while loop out of here. Instead of rendering 500 posts, we'll just remove this. We'll put the while loop here instead. And then we'll say this one component can wait for 500 milliseconds. And then here we'll just render slow component. Now the action is still being called inside startTransition, but because it's one big post, it's still going to consume the main thread, meaning React can't optimize it. So when we click this again, you'll notice that the UI will still freeze. So this is not the same as offloading the post to, say, a web worker and doing the work on a separate thread. So you just need to be aware of that because it can trip you up. Now in the second example, with the release of React 19, you can now pass async actions to startTransition. So the callback that you pass to startTransition is called an action. And previously, these had to be just regular functions. They couldn't be async. Now they can be async, meaning you can call things like network requests or any kind of promise within the body of the action. And then rather than managing the pending state ourselves, useTransition will already supply it. So when you call useTransition, it will return an array. The first variable is pending, and that will just be a Boolean telling us if the transition is running or not. So the second we call startTransition, this will toggle to true. And then only when we get to the very end and the callback returns will this go back to false. StartTransition is just a function that we call to trigger the transition itself. And then every set state call in here is queued up. So looking at the body of our component, we have a button here called update. And then when we click it, we trigger handle submit. That will call this function here. We have name and set name as state, which is used purely just to have a controlled component for the input value. And then we render an error if there is one. And then we also render the stored name. So we have some state here called server name, and this will be the value effectively that's stored on the server, even though update name in this case is just a fake fetch call. So when I put my name in, Warren, and then press update, you see the saving indicator, and then my name appears. Your stored name is Warren. So is pending is what's controlling the saving indicator. If I click this again, you'll see saving, And again, your stored name is Warren. So that means we don't have to manage the loading state ourselves. And since that's a very common pattern, this is a pretty nice one to have. Now, what if when we press update, we want to first clear the name whilst the request is in flight? What we could do is say, set server name to an empty string. And then when we click update again, the name disappears, saving, and then the name reappears once it's saved. If you were to put this inside the start transition and then call again, so I'll say Warren and then call it one more time, the name doesn't disappear this time. And that's because anything that you call inside a start transition is queued up and batched together. So that means that any set state call that you make won't actually re-render the component until the callback has returned, even if it's async. So when I say set server name here, that will get queued, then this promise gets executed, and then providing there's not an error, we call set server name, passing the name in. So this is basically redundant because this and this would just get called directly after one another. So you wouldn't really see it in the UI because they're only getting called once start transition has finished. So depending on the kind of functionality that you're actually after, then this can be a massive benefit that all of the set state calls are batched together. And if you don't want them to be batched together, just call them outside of start transition. Another hook introduced in React 19 is useActionState, and it basically allows us to manage form state in a much easier way than previously. This used to be called something else. I think it was use form state. Now it's changed to use action state in React 19. Here we have a very simple form. It's just got name, age, and then an update button. The way you may have done this previously in React is just like the example on the left here. So we have some state to track our errors, a pending state to track when the form is being submitted. Then we have a submit action attached to a form. When the form is submitted, we call submit action. Then the first thing we do is set pending to true so we can get a loading state. So if I just fill this in, we get a loading state for the button there. Then we send the form data to a fetch request, which would save the user to a server. In this case, it's just a mock request again, which waits for 1 second. If we do have an error, we set the error and then we set loading back to false. Now, with the introduction of the new hook, we don't need any of this state. So here is the same form using useActionState. useActionState will return the current state, the submit action, and is pending. Here, the only thing we're returning is an error because that's all that we're returning from this callback. So any value returned from the callback will be equal to this value here. In our case, it's just an error. Just change this. So this would just always be a string or null. We're rendering the error down at the bottom here. The submit action will go onto the action field of a form. So when the form is submitted, this callback will be executed. Then the pending state will automatically change as soon as the callback is executed. And then when it's returned, it will change back to false. So let's fill this form out with some bad data. We get a loading state and then the error shows up as well. Now we don't need to return error from here. This can literally be any object at all. So we might return an object for error. And then this would just be called something like state. And then we can say state.error down the bottom here. That means our initial state needs to change as well. So we could say error is null here. And then again, if there's no error, we return error null here as well. We also have access to the previous state. So if you want to do any kind of comparison between the current data and the previous data, for example, to check if a field has changed, you can do that by comparing the data from form data and previous state. So form data in this context is just the same form data that we've always had access to. So you can just call .get to get any of the fields available. And this hook is just pretty much one of those nice to have. So it doesn't really introduce any new functionality that you couldn't do before, but it does make the common use cases a little bit easier to work with. The third hook available is useOptimistic. And you can see React here is pretty much just looking at the common UI patterns that most of us follow and then providing us tools to make those patterns easier. useOptimistic is a really good example of that. So typically when we do things like submit a form, we might want to set the data optimistically before the server has returned. So in our case, we have your name is John. Let's change our name to Pete. And then when I press update, we're going to send a request to the server, but you'll notice the name updates instantly. And that's because I'm using the useOptimistic hook. So in our code on the left, we have the useOptimistic hook being set to the current name. In our case, that's John to start with. We then have a simple form at the bottom here. And then when we submit that form, we're calling our submit action. The first thing we do is grab the data for the name. We then call set optimistic name, passing in that name. So in our case, if I type something like Pete would get saved into Optimistic name instantly. We then call update name, which would pass the data to our server. So imagine this is a fetch request, and then providing there's not an error, we set the actual name stored here. So looking at the example again, if I type in Pete, press update, we instantly get Pete, and then because I've set current name here, that means the component has re-rendered. So current name has changed, and then that's been passed back into useOptimistic, and so Pete is rendered here. So what happens if an error occurs? In this example, if I type in the name error, we're going to return an error, in which case we won't call set current name. So I'll type in error, and then watch how the name instantly changes and then rolls back to John. Because we didn't call the final set state, so because this value didn't change, when this function has finished, useOptimistic will automatically roll back to the previous value. So we don't need to manage that kind of state ourselves, which is a really nice pattern. So these are the 3 main hooks available in the latest release, React 19. I hope this video helped, guys. If you want to see more like it, then please like and subscribe, and I'll see you in the next one.